Hello math enthusiasts, welcome to the section 6 part B of integrals. In this section we're gonna to discuss about something like this integration sine power 5 multiplied by cosine power 2, or integration of sine 4x times cosine 5x, or integration of tangent x with power 4 or cotangent x with power 5. The last tangent x power 4 multiplied by cotangent x with power 3, or something like this, tangent x power 3 times secant power 2. This integration I gonna to discuss. Okay, without any further ado, let's get started. Guys, but if I gonna to calculate these, I split sine x power 5 to sine x power 4 multiply by sine x, and I write this integration sine x power 4x times cosine x power 2 sine x dx. Right now, if I gonna to use this integration by substitution, I write this 1 minus cosine x power 2 cosine x power 2. If I put cosine x as a u, what happened for this? dx minus sine x is du. Therefore, this is minus du, and our integration changed to 1 minus u power 2 parenthesis power 2 u power 2d. Right now I open this parenthesis is 1 minus 2 u power 2 plus u power 4 multiply by u power 2, and I multiply for all this variable by u2 is exactly u2 minus t u4 plus u6. Am I right? But you must consider minus this integration. I put the minus in the out of integration. If I gonna to calculate this integration is minus u power 3 divided 3 minus u power 4 2 over 5 plus u power 7 divided to 7 plus c. Okay guys, if you not mastering trigonometry, I tell all these materials with detail in trigonometry playlist. But you must consider if you have a multiply to sine and cosine, or sine multiply by sine, cosine multiply by cosine, if you're gonna to change as a summation, you must use these formulas, and this exactly is number A, and I can use as a 1 over sine. A in here is 4x and B exactly is 5x. A minus B minus x plus sine 4x and 5x, I use this, yes, is 9x dx. But right now I can calculate it so easily because we know by trigonometry minus sine x equal to sine minus x. Yes, I can put it out is 1 over 2 minus sine is here, integration is cosine cosine x, but sine is in here, and integration is minus cosine, yes, minus cosine 9x, but divided to 9 plus c. But if I gonna to calculate these, our strategy for even and odd power is the same. And what is that exactly? If I gonna to calculate these, at the first tangent x power 4, I add by tangent reduced power by 2, tangent power 2x plus the first plus, at the last tangent x power 2 with minus with plus. You can see they are cancel each other dx. What we must do that, because this is simple, and I put this and this, and all these three factors I can calculate so easily. At the first I factorate the tangent x power 2 is is tangent x power 2 plus 1 dx. I take a minus, it's integration of tangent x plus 1 dx plus integration of 1 dx. These two factors is simple, but also this is also simple, because if I put u as a tangent x, our derivative is 1 plus tangent x power 2 dx. Yes, our integration is u power 2 du is u power 3 over 3. This integration is exactly minus tangent x, and that is plus x plus c. Right now you can understand what is our strategy when we have a tangent or cotangent with any power. In this type, we must add power n minus 2, and after that calculating our integration. For example, in here, integration of cotangent x power 5 dx, how we must calculate this guy? At the first, I put cotangent x power 5 with plus cotangent x power 2 minus cotangent x power 3 plus cotangent reduced by 2 cotangent x minus cotangent. Yes, they can cancel each other, they can cancel each other. But if I gonna to calculate integration, I put this by this one, and this separate and all. For our integration is cotangent x power 3 cotangent power 2 plus 1 dx minus integration of cotangent x power 2 plus 1 dx minus integration of cotangent x. You can guess, if we put the cotangent of x as a u, 1 plus cotangent x with a minus is du, and I put this minus in the out, minus u power 3 du, and in the here is exactly u minus and minus positive plus integration of u du, and we know in the last is positive. Yes, but we know that is exactly cosine x divided to sine x dx, and this part, the revision is in the top, is exactly u prime to u is ln u, and this integration of cosine x sine x dx. If I'm gonna to calculate this, is minus u power 4 over 4, this one plus u power 2 over 2, and plus ln sine x plus c. Am I right? Yes, it's a little progressing, and you must compute to receive at the last. But at the last, you must substitute u as a tangent. Yes? But the last question, guys, the second x is also by power 2 is 1 over cosine x power 2, and that is exactly 1 plus tangent x power 2. Am I right? Okay, therefore that is integration of tangent. I don't know why the mathematician used the second. It's not applicated, I think, because I just use sine, cosine, tangent and cotangent, and I solve everything by that. Maybe sometimes is therefore is not so useful a device. If I gonna to write this, is 1 plus tangent x power 2 times 1 plus tangent x power 2 dx, x power 6. If I put tangent x as a u, 1 plus tangent x power 2 is du or u prime, that is du, and our integration changed to u power 6 times parenthesis 1 plus u power 2 du, and if I multiply this by this parenthesis, is integration of u power 8 plus u power 6 parenthesis du. It's so simple, is is u power 9 over 9 plus u power 7 over 7 plus c, and at the last you just substitute u by tangents. Thank you for watching this video. If you are a new member, please subscribe and like because it takes me energy. See you in next session of integration. Take care. Bye bye.